In this tutorial, we're going to do a schematic driven layout using Mentor Graphics ICStation tool. Here's the inverter that we created in tutorial 1. The PMOS has been sized with a width of 12 and the NMOS has been sized with a width of 6. In this tutorial, we're going to take this inverter, create a design viewpoint, and then use ICStation to create the layout. Okay, so let's get started with ICStation. In order to create the first we need to do is create the design viewpoint. For that, first let's go into our Mentor Graphics working directory, type in cd $mgc_working directory. This will take me to my elect 442 VLSI folder. Now type in adk_dve. The name of my design is called my inverter. The technology I'm going to use is AMI05. So I type in adk_dve space my inverter space -t space AMI05. Enter. So this is going to create a design viewpoint for me so that I can do the layout based on the schematic. Okay. Now on the Linux prompt, type in adk_ic and the ampersand. This will bring up ICStation layout editor. Okay. First thing, let's go and look at some of the setup options. MGC, click on setup. This brings up this window. Click on the display. Under display, click on rulers grid. Make sure your snap grid is set to 0.5. Grid points at measured, you can leave it at 5 or change it to a 6. Hit apply. Say OK. Okay. Also, make sure go to MGC, location map, set working directory, and you can leave it at MGC_WD. Now let's create the layout. Go to File, New, Layout. We're going to use the existing viewpoint that we just created. So click on existing viewpoint. Now browse to my inverter layout folder. Say OK. Under logic, click on logic loading options. Flat. Say OK. Under cell name, give it a name. I'm going to call it my inverter. It's always a good idea to call it the same name as the schematic. On the process, click on the browse button, adk_. That will take you to technology, IC. Click on process, AMI05, say OK. Under rules, you go to the same adk, technology, IC, process, AMI05.rules, say OK. Click on options, attach library. Let's click on browse. Again, same $adk, technology, IC, process, AMI05. Say OK. Say OK. Now this would bring up a window for my inverter. Click on ADK, so ADK palette. Click on logic open. Sometimes this logic window opens together with the layout window. So up here I have two tabs. This tab is for where I'm going to do my layout. This tab is for my schematic that I created earlier. Okay. All right. Go up here to my layout window. Click on space. Space brings up this command, floating command bar. Okay. Type in PR. What PR does is brings in a VDD and a ground line into the design. If you measure the distance from VDD to ground, you'll see that it's exactly 120 lambda. Okay. Now let's go to my logic window. Up here, click on auto instantiate. Okay. What that does on the layout window is bring up a PMOS of width 12 and an NMOS of width 6. Okay. Now let's zoom out a little bit. We're going to move the PMOS down here and the NMOS down here. Okay. So let's zoom out. Select the PMOS. Click on move, either this, and place it down here. To unselect, press F2. Okay. Move and bring it down here. To unselect, press F2. Now let's zoom in that area. When you place it, make sure it's overlapped a little bit with the green. Okay. And up here, let's move this so that these two overlap. Okay. What we have on the screen now is a, let me move this here. Okay, now they're overlapped. VDD, PMOS, ground, NMOS. These yellow lines are called overflows. They basically exist to guide us as we create our routes, okay, or make our wires. Okay. First thing we're going to do is create a polysilicon line that connects the PMOS and the NMOS gates. So bring up the command bar by pressing the space and type in P, enter. This brings a polysilicon line of width 2. Using the overflow as a guide, connect the PMOS and the NMOS. Press escape when you're done. Let's connect the metal line for these two, and a metal line to VDD, metal line to ground. Space, M, enter. This creates a metal line of width 3. Notice how the overflow lines disappeared as soon as we wired them up. Okay. Okay. Now let's zoom in a little bit. Let's create a poly contact. So we have the poly line for the inputs, but we need to bring in the input from metal 2. So let's create a poly contact first. For that, command by pressing a space, type in PC, enter. Okay, let's move this closer to the and abut it with this. Okay. Now let's place the ports. Click on place port. Metal 1. Notice how you have the name metal 1Y. So let me put it up here. Metal 1A. The two ports that we placed are both in metal 1 currently. We want our input and output ports to be in metal 2. So highlight the port, go to the layer name and change that to metal 2. Hit apply. It'll change the color. Do the same thing for the output port. Metal 2, apply. Now let's move this a little straight. 2. Okay. Now let's wire this again. Space, metal route from here to here. To space, metal route. Now our ports are placed on metal 2 wire and our routes are in metal 1, so we need to connect metal 2 to metal 1 via using what we call a via. Okay. For that, do space, type PP, which means place port via, move it and place it directly over it. Space again, PP, which brings up port via. Okay. The next thing we're going to do is add port text. Now on the ADK edit menu you might have to scroll down, so scroll down and until you get add port text. Now when you did that, all the text is added. If you can't see it, zoom in, you'll see A, you'll see Y, and if you scroll up you should see VDD, and similarly you should see ground. Okay, all the ports are named, all the ports have been placed, all the ports have been named. Next thing we need to do is add a N-well contact and a P-well contact. Press the space bar, type in NWC for the N-well contact, bring it and place it right here. Again, scroll down, just bring a space bar, P-well contact, PWC, place it right here. Now we should be done. We should be done with the design of our inverter. We should have our completed inverter. Next thing we need to do is make sure that we have not violated any design rules. So there is design rule check. Scroll down on the ADK edit menu. On the verification you'll see DRC. On this button, on the right hand button, click, hit check, say OK. Okay. If there was no error, you will see total rule check, number of rules that were checked, total results 0. Total results 0 means your design did not violate any design rules. Okay. If there was any kind of violation, you would see total results number greater than 0. In that case, you do DRC first to figure out where the first error is, next to figure out where the next error is. So this is how save this design. This is how you do a schematic driven layout using ICStation tool.